For today's lesson, we will be discussing about limits of transcendental functions. So it includes exponential, logarithmic, and trigonometric functions. So let's define first what is a transcendental function. So it is a function or functions that cannot be expressed as a sum, difference product, or quotient of algebraic expressions. So comparing it with algebraic functions such as polynomial, rational, and then the roots of a polynomial or radicals, these functions, the transcendental functions, we cannot express them as the sum, again, difference product, or quotient of the different algebraic expressions. So the term transcendental means that the function is not algebraic. So we have three transcendental functions. We have the exponential function, the logarithmic function, and also the trigonometric functions. So we will be discussing how to identify the limit of those transcendental functions. So let's start with limits of exponential functions. For any a, which is element of real number, the limit of e raised to x as x approaches a is just equal to e raised to a. And if b is greater than 0 and b is not equal to 1, then the limit of b of x as x approaches a is also equal to b raised to a. This means that we can just do direct substitution as long as the conditions here are satisfied. So let's have an example. So let's say we have to evaluate the limit of 3 raised to x as x approaches 2. So since this one is an exponential function, so what we can do is just to substitute the value of a to the function, which is 2. So this will become 3 raised to 2, or the value that we have now is 9. So therefore, the limit of this function 3 raised to x as x approaches 2 is equal to 9. So for limits of logarithmic functions, let b be greater than 0 such that b is not equal to 1. Then the limit of the logarithm of x base b as x approaches a is equal to the logarithm of a base b, provided that a is greater than 0. So here, we will just do again direct substitution, and we will still be following the different laws or rules that we do in evaluating logarithmic expressions. So let's just have this example. Let's identify the limit of logarithm of x base 2 as x approaches 8. So since this one is a logarithmic function, so we can just do direct substitution. Logarithm of 8 base 2. So make sure that you still know how to simplify or how to evaluate logarithms. So in logarithms, we are identifying what exponent are we going to use to the base so that we will arrive at the argument, which is in this case is 8. So the answer here should be 3. So when we raise 2 to 3, we will get 8, which is the argument. So therefore, the limit of this function as x approaches 8 is equal to 3. Now let's evaluate more limits involving exponential and logarithmic functions. So let's have another example. Let's identify the limit of 3 times 2 raised to x plus 5 as x approaches negative 1. So this is an exponential function. So we can just do direct substitution. 3 times 2 raised to negative 1 plus 5. And then simplify. So we have 3 times 2 raised to 4. 2 raised to 4 is 16. Then you multiply it to 3. So we will get 48 as our answer. So that is now the limit of our function as x approaches negative 1. Another example. Limit of 1/2 times e raised to 3x plus 7 as x approaches negative 2. So again, what we can do is just do direct substitution. So we have 1/2. And then we have e, and then raised to 3 times negative 2 plus 7. And then you simplify this. So this is 1/2. And then we have e, and then raised to, this one is 3 times negative 2 is negative 6 plus 7. So we'll have 1 as the exponent of e. And since e is raised to 1, so that is just equal to e. And then multiply it to 1/2. So you can just write 1/2 e, or you can write it as e over 2. So this will be your answer. E here is the natural number, so we will just treat it as like how we treat pi. So again, the limit of this function as x approaches negative 2 is e over 2 or 1/2 e. Okay, next example. Let's say we want to identify the limit of 3 times 4 raised to 5x plus 3 minus 5 as x approaches 2 over 5. So let's substitute again. We have 3 times 4 raised to 5 times 2 over 5 plus 3 and then minus 5. So let's simplify the exponent first. So this will be 4 raised to, this will be cancelled, and then you will just have 2 plus 3, which is just 5, then minus 5. Now let's simplify 4 over 5 first, and that is 1024. So it's 3 times 1024, then minus 5. Then simplifying this even more, we will get 3072 minus 5, or our final answer now will be 3067. So this is now the limit of the given function. Another example, let's say we have to identify the limit of ln of 5x minus 9 as x approaches 2. So this one is a logarithmic function, and as you notice, we have here ln. Now, if you see ln, that means we are having natural logarithms. And when we talk about natural logarithms, that means the base is e, or our natural number. So that is one thing that you have to keep in mind. But still, we will be applying the same rules like what we did with ordinary logarithmic functions. So let's substitute. So we have ln of 5 times 2 minus 9. So this is now equal to ln of 5 times 2 is 10 minus 9. So this is equal to 1. Now we have to get the ln of 1. So remember, ln, the base is e. So we have to think of a number that we will use as the exponent of e so that the answer is 1. And that is 0. Because remember, if we raise e to 0, that will give us 1. Any number raised to 0 is just equal to 1. So therefore, the limit of this function as x approaches 2 is equal to 0. So let's try this example. So let's just substitute. So we have logarithm of, and then negative 4 squared plus 9 minus 4. Forgot to put the base here. So we'll have simplified the one inside the grouping symbol, logarithm of 25 minus 4. So you solve for this one first before you subtract 4. So logarithm of 25 base 5 is 2, and then minus 4. Therefore, the limit of this function is negative 2. Let's try another logarithmic functions. So let's just substitute. Logarithm of 2 times 5 plus logarithm of, then we have x squared, so 5 squared plus 5 minus logarithm of 5 minus 2. So let's simplify this. Logarithm of 10 plus logarithm of 25 plus 5 is 30 minus logarithm of 3. Now you notice that all of them, they have the same basis. That means we can apply the limit laws to simplify this. So notice that the first two are connected with addition. So we can apply the first law of logarithms, which is the addition law, meaning we can combine the two by multiplying their arguments. So let's multiply 10 and 30. So that will give us 300, or logarithm of 300. And then we have here minus logarithm of 3. So for this, since the two are connected with subtraction, we can apply the second law of logarithm, which is the subtraction law. So we can combine the two logarithms by dividing their arguments. So that will be 300 divided by 3, which is now logarithm of 100. And then from here, we can now get the value of that, which is equal to 2. Remember, this one, the base here is 10. So 10 raised to 2, that will give us 100. Now for the limits of trigonometric functions, let a be contained in the domain of the function whose limit is being evaluated. So we will assume that the a, or we have to make sure that a is part of the domain of the given functions. So for this one, all we have to do is just to substitute the value of a given to us to the given function. So, for example, limit of sine x as x approaches a. So, that is just sine of a. Limit of cosine x, that is just cosine of a, and so on. So, again, for the limits of trigonometric functions, we will just substitute. And of course, we have to apply the rules or the ways on how we evaluate trigonometric functions. Let's start with the first one. So, limits of cosine 4x as x approaches pi over 6. So, if we substitute that, we have cotangent of 4 times pi over 6. So, you multiply that, that will give us 4 pi over 6. Or if we simplify it, that will be 2 pi over 3. So now we have to get the cotangent of 2 pi over 3. There are different ways on how you can get the cotangent of 2 pi over 3. So you can use the trigonometric points if you want. If you want to use the trigonometric points, then you can just simply use the unit circle. So, 2 pi over 3 in degrees is 120. And from the unit circle, so this is 120, we can say that it has the same trigonometric points as the 60-degree angle. So, the trigonometric points of the 60-degree angle is 1/2 square root of 3 over 2. But since 120 is in the second quadrant, therefore, we will just change the sign of x. So it will become negative 1/2 and square root of 3 over 2. So you can use the trigonometric points to solve for the cotangent. And the formula that we will be using is x over y. So just substitute the values, negative 1/2 over square root of 3 over 2. So let's just continue this. Negative 1/2 times 2 over square root of 3. So you should already know how to simplify this. So get the reciprocal. Cancel. We have negative 1 over square root of 3. And then we rationalize. So we now have a negative square root of 3 over 3 as our answer. So that is now the limit of our cotangent for x as x approaches pi over 6. Actually, you can also use your calculator if you want. Since in our calculator, we don't have the cotangent, what we have is just the sine, cosine, and tangent. So we can use the tangent. And we know that tangent and cotangent are inverses of one another. So you can just input there 1 over the tangent of 2 pi over 3. And you should also get negative square root of 3 over 3. Okay? Just make sure that the settings in your calculator is correct. So make sure it is in radian. And for our last example, limit of the secant 3x plus pi as x approaches pi over 2. So let's substitute this. So we have secant of then 3 pi over 2. So 3 times pi over 2 plus pi. Or this is just secant of 3 pi over 2 plus pi. So let's simplify this. So you add 3 pi over 2 and pi. So that will give us 5 pi over 2. So we now have to identify the secant of 5 pi over 2. Now, if you want to use the trigonometric points, so you have to identify the trigonometric points of 5 pi over 2. In degrees, 5 pi over 2 is 450 degrees. And if you will visualize it in our unit circle, so it will complete one full rotation, that's 360. And then the remaining is 90 degrees. So you will complete 450 degrees. So it will end now at the 90-degree angle. So that means 450 degrees and 90 degrees have the same trigonometric points, which is 0 and 1. So we can use this again to solve for the secant of our function. Since we are solving for secant, that means that is just the reciprocal of the cosine, or that is 1 over x. So since we already have the points here, so x is 0, so this will be 1 over 0, or it is now undefined. Now if it is undefined, that means the limit does not exist. Because if you will check the graph of this, from the left and from the right, they are going to different directions. So they will not meet at a certain point. So that's why the limit here does not exist. So if it becomes undefined, after you substitute the value of x, that means the limit does not exist. So if you want to use your calculator in solving this, you just have to consider the reciprocal function of secant, which is the cosine. So you can just type in there 1 over cosine of 5 pi over 2. So you will again get a math error, which means the limit does not exist. So that's it for today. I hope you learned something about the transcendental functions, as well as how to evaluate the limits of these kinds of functions, and see you next time.